Hi, this is Victor Morganti from FactEngine. Today we'll be looking at semantic search with FactEngine, and in particular we're going to be looking at Schema Aware Semantic Search. We've got FactEngine open in front of us inside the Boston conceptual modelling software, and please note that FactEngine will be available as a API web-based for the types of queries we're going to be looking at today. The FactEngine allows you to write natural language queries over a database where a model or a schema for that database is presented behind FactEngine. So in natural language we might say, what movies are showing at the Great Western Cinema today? So that's a natural language query, and we know in FactEngine that natural language queries get converted to controlled natural language, and that controlled natural language is converted to a database query language executed over the database. So what movies are showing at the Great Western Cinema today has been converted to which film is showing at the cinema, Great Western Cinema, on date, time, and we want the date of the date, time, and where that matches today. And the results that come back is Rocky and Grease, and there's a database query behind that. FactEngine caters for SQL, Cipher, or TypeQL for TypeDB. This database is on a SQL database, and that's the SQL to get the results. The movies Rocky and Grease are showing at the Great Western Cinema today. So the natural language query, a semantic query, in this case is schema aware, so it's aware of the schema of our database to be able to form a controlled natural language query, which film is showing at the cinema, Great Western Cinema, on date, time, date, matching today, to get our results. And the schema behind the controlled natural language query is something that you produce inside the Boston conceptual modelling software, either as a property graph schema, and we can see properties if we click on a node type in the property graph schema. So a cinema has a cinema ID and a cinema name, a seat has a cinema ID, a row and row number, a letter, and a section name of the section that it's in, and where a section is identified by its section name. So that's a property graph schema. In Boston you can have a entity relationship diagram for exactly the same schema, and a object role model for exactly the same schema. And the secret sauce of FactEngine is that the model is identical between the property graph schema, the entity relationship diagram, and the object role model at its core. So that is our schema, and it's easier for us to understand our schema if we work through it. The schema is for a database for bookings for seats at cinemas to watch movies, and that's open in the Model Explorer on the left hand side, and where this model is a derivation of a cinema bookings model initially developed by Data Constellation and shared on GitHub. So we have a person node type, and where a person can make one or more bookings, and where a booking is for one or more seats, and where a booking is for a session that's at a cinema, and the session is to watch a film. The predicates, or the edge labels, between the node types helps us in our translation from natural language to controlled natural language, and we'll be focusing in on that in this video, and this is one of a series of videos that I'll be making on semantic search with FactEngine. To get a feel for that, if we go back to the property graph schema view and we focus in on session, if I click on session, it has a series of readings that can apply for a session, and I'll give you an example of that. So film is showing at cinema on date time, or you could read it as film on date time is showing at cinema, or cinema is showing film at date time, or film is showing on date time at cinema, or date time has film showing at cinema. So there are different ways that you can talk about exactly the same thing, which is a session. And FactEngine, in this case, is using a large language model, so a generative pre-trained transformer model that has been trained on this particular domain. So it's a domain specific training on that generative transformer to understand that when we write natural language queries, they can be transformed to controlled natural language queries having the predicates that are used to identify various node types or edge types in the case of a property graph schema, or tables and the relations between tables in a entity relationship diagram, or in the case of the same model expressed as a object role model, if we look at session here, session is a fact type that has those same fact type readings. So when we say what movies are showing at the Great Western Cinema today, the transformer model translates that to which film is showing at Cinema Great Western Cinema on date time, date matching today, which matches to one of our readings for a session, film, cinema and date time. So film, the top one, film is showing at cinema on date time. To be able to generate our our database query, in this case SQL, to get our results. So if I execute that and get our results, Rocky and Grease. Now, the benefit of using object role modeling, if we focus in on the session fact type, which relates to the session node type in the property graph schema view, or the session table in the entity relationship diagram, is that the fact type has three roles, and depending on where the object type sits inside that fact type, different fact type readings apply for that session. But not only that, there is a special type of fact type in object role modeling for objectified fact types called a link fact type, which apply to roles, in this case that role coloured purple, where we're looking at the relationship between a session and the film that's being shown at that session. And if I click on that fact type, I can see that it has fact type readings, where we can say film is for session, or session is for film, or session is to watch film. Now there's a link fact type for each of the roles in that particular fact type, and it allows us to do things like, say, ask questions. Which session is showing the film Rocky at the Great Western Cinema today? Now, I haven't trained the generative transformer on this particular question, so it'll be a good test to see how successfully that's translated to a controlled natural language query against that particular schema. So let's hit go on that. Now that's going to translate to a controlled natural language query. Which session is showing the film Rocky at the cinema, Great Western Cinema, on date, time, with the date matching today? So that session is showing the film Rocky comes from our object role model, where between session and film there's a link fact type, and where if we look at the readings for that, we're saying session is to watch film. And FactEngine has actually been smart enough to recognize that there's only one fact type between session and film, so is showing is good enough for FactEngine. So that could be another fact type reading between session and film. So we can add that session is showing film. We don't want to change the fact type name, so that's now another way of identifying that relationship. Now these types of relationships, you might think, well, they don't relate to my Neo4j database. Well, they do, because you can implement multiple properties within a Neo4j database that can equate to a unique key, and especially in Neo4j Enterprise. And even in Neo4j Enterprise, the requirement that a particular property is populated whenever the relationship between that node type and another node type manifests, and we can see that better inside the property graph schema view. So what we're saying is that for each session that is to watch a film, this session will store the film ID of the film. So let's look at film. Film has a film ID property and a name property, and a session has a film ID property, a date time property, and a cinema ID property. In Neo4j Enterprise, you can say if you have this edge type between session and film, you must populate another property, and it doesn't specify what you populate it with, but presumably in this case you would populate it with the actual film ID of the film that relates to that edge type. And we can in Boston, we can actually look at some of the data in the database behind the scenes here. So the film IDs, the date times, and the cinemas that manifest as a session. So our semantic search in natural language is schema aware based on the schema of our model of our database, to be able to form controlled natural language to form our database query, such that we can ask quite complex queries, such as which seat has a booking to watch Rocky at the Great Western Cinema today. So I'm going to hit enter on that. It's going to transform to controlled natural language and return a result. So we've got a seat with a cinema ID of 1, a row number 1 and a letter A. So the seat 1A at the Great Western Cinema has a booking to watch Rocky today. Now what that query has done is looked at the schema and said which seat has a booking to watch the film Rocky. So the booking has a session to watch a film at the Great Western Cinema, and that's what our query says. So which seat has a booking for a session to watch the film Rocky at the Great Western Cinema on today's date? And we could ask something like who has a booking to watch Rocky at the Great Western Cinema today? So that should translate to which person has a booking for a session to watch the film Rocky at the Great Western Cinema. So that's successfully translated to which person has a booking for a session to watch the film Rocky at the Great Western Cinema on today's date, and the result has come back Peter. So if we look at our model, we were asking which person has a booking for a session to watch the film Rocky at the Great Western Cinema, but our natural language query didn't mention session at all. Our natural language query just said which person has a booking to watch the film Rocky at the Great Western Cinema, and the pre-trained generative transformer, or the generative pre-trained transformer, converted that successfully to a controlled natural language query which matches our schema for our database. So what we've looked at today is semantic search with FactEngine, so natural language queries inside FactEngine over a database, and where those queries are schema aware. So we're doing Schema Aware Semantic Search with FactEngine. Thank you very much for watching. I hope you liked the video. If you liked the video, please hit like and subscribe, and I'll see you in the next video.